Hello, business algebra. Now we just did linear modeling, but in reality, most things in the world aren't linear. So we're going to deal with quadratic. Now generally, a polynomial has various degrees that you can look at, and it has terms. The degree of the polynomial is based on the largest exponent that you see. So linears, of course, have the largest exponent of 1. Quadratics have the largest exponent of 2, so it's the x squareds. You might know those as parabolas. In general form, a function is quadratic if it's the form f of x equals ax squared plus bx plus c, with a, b, and c element of the complex numbers, which means they can't have imaginaries. We're only going to be dealing with reals, and a can't be 0. If a were 0, it would be a linear or a constant. So we'll be looking at quadratics with real coefficients. As a reminder, the most simple quadratic function is f of x equals x squared. It has these various things. This is the parabola most of you have probably seen before. And this shape has some unique properties, mainly that we'll use. Some of which are that the maximum or minimum occurs at negative b over 2a, and it either has only one maximum or only one minimum, and otherwise it has none of the opposite of those. It has some either increases or decreases to the max or min, depending on what's happening. But you can read about these on the front page, and let's talk about some more features that it has before we get to some math. The easiest form for graphing is vertex form, which is f of x equals a times x minus h squared plus k, because it gives you the vertex. For our purposes, that's usually pretty valuable to find the maximum or minimum, because the max or min automatically occurs at the vertex, and that's at hk. Now, what does every part of the function equation tell us? If a is positive, it opens upward. If a is negative, it opens downward. Opening downward is when it has a max. Opening upward is when it has a minimum. We're not worried too much about the vertical stretch for now. We'll worry about it when we're graphing. Usually we plug in points to deal with that. If h is positive, so if it's like x minus 2, that moves the parabola to the right. If h is negative, it moves it to the left. Again, something we'll worry about when we graph. If k is positive, it moves the parabola up. K is negative, moves the parabola down. Generally speaking, the features are the vertex is at the point hk. The maximum and minimum is the value k at the point x value h, and it's symmetric about the line x equals h, which will help us for graphing, that last one. The other two are useful for some word problems. For the standard form, ax squared plus bx plus c, the vertex is more complicated than just hk. It's negative b over 2a and 4ac minus b squared over 4a. Now that y value looks scary, you don't have to memorize that. Remember, this is an xy coordinate. If you remember that x equals negative b over 2a, you can plug in your x value to get the y value that goes with it. So you don't need to memorize this. Just know that the vertex for a quadratic occurs at negative b over 2a. Let's do a few things. First, determine the vertex of the function f of x equals 2 times x plus 3 squared plus 5. Okay, again, when it's in vertex form, it's just hk. But remember, this is 2 times x minus h squared plus k. So generally, for your x value, it's the opposite sign from what you see inside the parentheses with x. So if it's x plus 3, it's really negative 3 for x, but the y value is whatever's on the outside. So our vertex is at the point negative 3, 5. And that's it. Determine the vertex of the function f of x equals x squared minus 4x plus 2. So this is where I said this is standard form. You need x equals negative b over 2a. then you'll plug that in to get y. So b is whatever's in front of x, negative 4 over 2 times a is whatever's in front of x squared, 2 times 1. That would be negative 4 is 4 over 2, which is 2. So we know for a vertex, the x value is 2. Now to find the y value, let's plug that in. F of 2 is 2 squared minus 4 times 2 plus 2, or 4 minus 8 plus 2, which is negative 2. So our vertex is 2, negative 2. It says graph the function from number 2 by plotting the vertex and plugging in points. So we know we have the point 2, negative 2. Because it's positive in front of the x squared, we know it's opening upward. But if we just want to plug in points, we can use symmetry to our advantage. What's near 2? 1 or 3. And because of symmetry, they're going to have the same value. So let's plug in f of 1 is 1 squared minus 4 times 1 plus 2. 1 minus 4 plus 2, which is negative 1. So 1 and 3 both go to negative 1. Let's plug in 0, 0 and 4. F of 0, we know when we plug in 0, all of the x's are going to disappear. So the only thing, 0 squared minus 4 times 0 plus 2 is just 2. So we have 0, 2. That means we also have 4, 2. And we'll do one more. This should be enough to get a general sketch, but let's plug in negative 1 or 5. I'm going to plug in 5. 5 squared minus 4 times 5 plus 2. It's 25 minus 20 plus 2, which is 7. So we've got 5. 1, 2, 3, 4, 5, 6, 7. We also have it for negative 1. Connect the dots. And we have a quadratic. So once you get the vertex and you get a few points around the vertex, you'll have an idea of what the graph looks like. Okay, let's do some word problems. Shanice owns and operates her own microbrewery. She hired a consultant to analyze daily profits for the sale of X cases of beer. These profits were determined to be P of X equals negative X squared plus 120X. Determine the vertex and find out if it's a maximum or minimum. Create a rough sketch. Okay, again, the vertex is at negative B over 2A. In this case, that's negative 120 over 2 times negative 1. So negative divided by negative is positive. 120 over 2 is 60. Okay, so 60 is the x value. Let's plug in 60. P of 60 equals negative 60 squared plus 120 times 60. This is negative 3,600 plus 7,200, which is positive 3,600. So her daily profits for selling 60 cases of beer is $3,600. If she makes that every day, she's going to make over $1 million a year, which is a nice profit. Okay, so we have the point 60, 3,600. How do you determine if it's a max or min? Because it's negative, we know it's a downward-facing parabola, and downward-facing parabolas have to have a maximum and not a minimum because they go down forever on the sides. It's a max. A rough sketch. We don't need all of the quadrants. We really just need the first quadrant. Obviously, producing 0 beer will give you nothing. At some point, she reaches a max because it's a parabola at 60, 3,600. And then it goes back down. This is 120, 0, and 0, 0. You can plug them in to find them. That's what it looks like. And we will continue in the next video.